Welcome to Summarize Science. Have you ever talked to someone who was completely wrong but sounded incredibly sure of themselves? It turns out that AI models, specifically multimodal large language models, have this exact same problem. Researchers call this perceptual bluntness, where the AI acts confident even when it cannot see the image clearly. As you can see in this graph, when the image quality drops, the AI's accuracy falls off a cliff, but its confidence stays strangely high. This gap represents a major safety issue because we cannot trust the model to know when it is just guessing. The researchers found that models often suffer from severe miscalibration, maintaining high confidence even under heavy noise. To solve this, they introduced a two-part framework designed to link perception, confidence, and accuracy together. The first part is a training method called CDRL that rewards the model for being honest about its uncertainty. By using pairs of clear and noisy images, the system teaches the AI that it should be less confident when visual evidence is missing. This training helps the model develop perceptual sensitivity, making it much more aware of what it is actually looking at. The goal is to link the model's accuracy directly to its self-reported certainty levels. The second part of their solution is a system called CTS, which stands for Confidence-Aware Test Time Scaling. This system uses an expert model to act as a manager for several different reasoning tools. One tool is the voter, which looks at many different possible answers and weighs them based on how confident the model is. Another tool is the critic, which looks for mistakes in the model's logic and asks it to rethink the problem when confidence is low. There is even a self-check module that compares the original image to a noisy one to ensure the AI's logic is actually based on the picture. An expert planner decides which of these modules are needed for any specific question. When they put this entire framework to the test, the improvements were very impressive. The model outperformed standard baselines by about 8.8% across 4 different major AI benchmarks. This demonstrates that a more honest model is actually a more capable model. This chart shows that as the model is allowed to think longer or take more samples, its accuracy improves much faster than older methods. The slope of the blue line indicates a superior scaling potential thanks to that calibrated confidence. It proves that knowing when you are confused is a huge advantage for solving complex problems. They also tested the system against various types of visual distortion, like covering parts of the image or changing the viewpoint. In every case, the new training helped the model correctly drop its confidence when the image became too hard to understand. Compared to older methods like tree of thoughts, this approach is much more resilient to single mistakes. Here is a real-world example where the AI initially guessed wrong but used self-reflection to catch its error. By having a critic point out the specific mistake, the model was able to reconsider and arrive at the correct answer. This multi-stage process ensures that the final result is verified through several different layers of logic. To recap, researchers have found a way to stop AI from being overconfident when it is actually confused. They achieve this through smarter reinforcement learning and a system that allows the AI to double-check its own perception. This research marks a shift from just making AI smarter to making AI more self-aware of its own limits. In the future, this could lead to much more reliable AI assistants that will not hallucinate or lie with a straight face. It is a huge step toward building machine intelligence that truly knows what it sees and knows when it does not know. Thanks for watching Summarize Science.